Good day everyone. Can you solve this infinite series question? Here's the question. Evaluate 1 over 1 times 2 times 3 plus 1 over 3 times 4 times 5 plus 1 over 5 times 6 times 7 plus 1 over 7 times 8 times 9 and so on and so forth. You can pause this video if you want to give this problem a try. And now let's answer this question together. So our goal here is to evaluate this infinite series. So how are we going to evaluate this kind of series? Now, here's one way to do it. First thing is let's focus on this term 1 over 1 times 2 times 3. This reminds me of the identity that says that if we have 1 over n times n plus 1 times n plus 2, we have consecutive integers on the denominator. This is equivalent to just 1/2 multiplied by 1 over n times n plus 1 minus 1 over n plus 1 times n plus 2. So using this identity, we can say that 1 over 1 times 2 times 3 can be written as 1/2 multiplied by 1 over 1 times 2 minus 1 over 2 times 3. Now, before we use this identity, let's verify first that the right-hand side is equivalent to just 1 over 1 times 2 times 3. So let's watch this. Now, clearly, we can see that this is just the same thing as 1 over 1 times 2 times 3. So, we can replace this 1 over 1 times 2 times 3 as follows. 1/2 times 1 over 1 times 2 minus 1 over 2 times 3. Now, we will do the same thing on this expression 1 over 3 times 4 times 5. Using this identity, this is just 1/2 multiplied by 1 over 3 times 4 minus 1 over 4 times 5. So, we can replace 1 over 3 times 4 times 5 by 1/2 times 1 over 2 over 4 minus 1 over 4 over 5, like this. And also, 1 over 5 times 6 times 7 can be written or can be replaced by 1/2 multiplied by 1 over 5 times 6 minus 1 over 6 times 7. And then now, take note that we have a lot of 1/2 outside the parentheses. So 1/2, 1/2, and 1/2. So what we're going to do is to factor out 1/2. So again, what we did is we factor out this 1/2 outside of the parentheses. 1/2, 1/2, and 1/2. Alright. And now, let's focus on this expression 1 over 1 times 2. Because again, let's recall this identity. If we have 1 over n times n plus 1, we have the product of two consecutive integers. That is equivalent to just 1 over n minus 1 over n plus 1. So, 1 over 1 times 2 can be written as 1 over 1 minus 1 over 2. Now again, let's verify this before we use this identity. Let's watch this. And now clearly that 1 over 1 minus 1 over 2 is the same thing as 1 over 1 times 2. So we can replace 1 over 1 times 2 with 1 over 1 minus 1/2. And now let's simplify. 1 over 1 is just 1. Now how about 1 over 2 times 3? Using this identity again, this can be written as 1 over 2 minus 1 over 3. So we can replace this 1 over 2 times 3 with 1/2 minus 1/3. But take note that the operation is subtraction, so we need to use parentheses right here. Alright. Now 1 over 3 times 4 is just 1/3 minus 1/4. 1 over 4 times 5, we have subtraction sign, so we need to use parentheses. We have 1/4 minus 1 over 5. 1 over 5 minus 6 can be written as 1 over 5 minus 1/6, and we will do the same thing in this 1 over 6 times 7. And now, let's clear the parentheses. Let's distribute this negative 1 to 1/2 and negative 1/3. So this will give us negative 1/2 plus 1/3. We will do the same thing in this 1/4 minus 1/5. Let's multiply this by 1/2. And on this 1/6 minus 1/7. And now let's simplify. This negative 1/2 minus 1/2 is just negative 1, of course. Then 1 minus 1 is just 0. This is gone. So this will give us 1/2 times 2 1/3 minus 2 1/4 plus 2 1/5 minus 2 1/6 and so on and so forth. Now, 1/3 plus 1/3 is just 2 over 3. We can write this as 2 over 3. Negative 1/4 minus 1/4, or we have 2 negative 1/4, so we can write this as negative 2 over 4. Also, 2 1/5 can be written as 2 over 5. 2 negative 1/6 can be written as negative 2 over 6, and so on and so forth. Whew. Now, we have a lot of 2's on the numerator, so what we're going to do is to factor out 2, of course. So this will give us 1/2 times 2 times 1/3 minus 1/4 plus 1 over 5 minus 1 over 6 plus 1 over 7, so on and so forth. Now 1/2 times 2 is just 1. Therefore, our infinite series a while ago can be trimmed down into 1/3 minus 1/4 plus 1 over 5 minus 1 over 6 plus 1 over 7, and so on and so forth. Now, this infinite series is familiar if we recall the Taylor series expansion of ln of 1 plus x, because ln of 1 plus x is equivalent to just x minus x squared over 2 plus x cubed over 3 minus x raised to the 4th power over 4 plus x raised to the 5th power over 5 minus x raised to 6 over 6 plus x raised to 7 over 7, and so on and so forth for all x that is greater than negative 1 but less than or equal to 1. Now, what will happen if we let all x be equal to just 1? This is possible. On the left hand side, this is just ln of 1 plus 1, or just 2. Now, this 1 raised to 2, this 1 raised to 3, this 1 raised to 4, up to 1 raised to 7, and so on and so forth. This is just 1. And now, take a look at this. We have 1/3, negative 1/4, negative 1/4, 1/5, positive 1/5, negative 1/6, negative 1/6, positive 1 over 7, positive 1/7, and so on and so forth. So, to get this value, what we're going to do is to simplify first. 1 minus 1/2 is just 1/2. And now, let's subtract 1/2 on both sides. And now, this is exactly this expression right here, this infinite series right here. 1/3, negative 1/4, or minus 1/4, plus 1/5, minus 1/6, plus 1 over 7, and so on and so forth. Therefore, this infinite series is equivalent to just ln of 2 minus 1/2. Therefore, our answer to this question is simply the value of this infinite series is just ln of 2 minus 1/2. And as always, we are done.